Hey everybody, welcome to video number 12, polar and nonpolar molecules. So this is different than bonds. So now we're going to look at the collection of bonds that make the entire molecule and look at that whole picture all at once. Okay, and we got to figure out what symmetry is to help us figure this out. So first, polar covalent molecules are what we call asymmetrical. Okay, you might want to save room for each example because I know you only have a little bit of space. So if you can save some room on the one side for the example, you'll be all set. Okay, asymmetrical first means that the molecule will fail the mirror image test either north-south or east-west. You're going to cut that thing in half and one side's not going to be the same as the other. If that happens, that is asymmetrical. Okay, any failure of the mirror test means it's asymmetrical. And this basically means the molecule will not be perfectly the same on each side. So let's do a quick example and you'll understand what I'm talking about. So first one up, ammonia, NH3. When I cut it up and down, notice it's the same on both sides now. So it's perfectly mirror image one side to the other. So that's good. It passes that mirror test. Okay, but now we need to cut it the other way. So when I cut it crossed, now the top and the bottom do not match. They are not the same on the top and the bottom. Notice there's 2 electrons up top, there's a hydrogen on the bottom. That is not the same. Therefore, this is asymmetrical. Asymmetrical means that the molecule is polar. You might need to write that there. Asymmetrical means the molecule is polar. Okay? All right, let's go for symmetrical. Okay, symmetrical are nonpolar covalent molecules that do not have any polar sides. Okay, so symmetrical means that the molecule will pass the mirror image test on both north-south and east-west. It is the same all the way around. So must pass both to be symmetrical, and this means the molecule is the same on all its sides. So let's give you an example of that. You can write this over in the side or whatever. So first example, methane, CH4. If I cut it up and down, check it, it's the same left and right. Good. And if I cut it across, it's the same top and bottom. So this passes both tests. So this is symmetrical. Symmetrical molecules equals nonpolar. You need to write that little piece in. Notice I didn't have nonpolar come flying in. This is a nonpolar molecule. There's no obvious difference on one side of this thing to make it a negative and a positive. Okay? Now we got some examples. We're going to talk about some solubility first. All right, well, polar solids will dissolve in polar liquids. That's what like dissolve like means. And nonpolar solids will dissolve in nonpolar liquids. Okay, so I need the polarities to match up between the thing that's being dissolved and the thing that is dissolving. Okay? Water is considered the universal solvent because it is not only polar, but it's also covalent. Ionics are polar by nature, so most of them will dissolve in water. Table F will tell us who doesn't. We'll get into that in the solutions in depth, okay? Symmetry and polarity examples. So let's draw some and then figure out what's going on with bond polarity and molecular polarity. They're two different things, okay? So first, HCl, I'm going to draw this fast because we're getting good at it. I got H bonded to Cl, bring in my lone electrons. And my bond polarity, I need to look up the electronegativities, and we're going to find that this is going to be polar covalent. So I'm just going to write PC for polar covalent because this is like 3.4 minus 2.2 is in between 0.4 and 1.7. Now, molecule polarity, when I cut it this way, it's the same top and bottom. But when I cut it this way, it's not the same. So this is a polar molecule. See how we did that? And these don't always match. Polar covalent bonds do not always make polar molecules. So we can't make those jumps or those connections. Okay, NH3, let me draw this one pretty quick. I got N bonded to 3 H's. And I know there's 2 lone electrons up top. This was part of our notes. Bond polarity, nitrogen and hydrogen. Let's see. Nitrogen is going to be at 7, 3.0. And hydrogen is 2.2. So its electronegativity is 0.8, which makes it polar covalent. And then molecule polarity When I cut it this way, it's the same, but when I cut it this way, it's not. So this is polar. Polar molecule overall. Okay, H2O, drawing them fast. Oh, 1, 2, 3, 4, 5, 6. That's going to give me an oxygen. Whoopsies. Hydrogen there and there. Between oxygen and hydrogen. Oh, killing me, Smalls. Trying to redraw this to look a little better. Oxygen is 3.4, I think. I've just seen it so many times. And hydrogen's 2.2. When I subtract those, that's 1.2. So that's, again, polar covalent bond. The bond between one oxygen and one hydrogen is polar covalent. And then when I cut it this way, it's not the same on both sides, so it is a very polar molecule. There's an obvious positive side and an obvious negative side. All right, O2. It's going to look something like this. It's going to be completely non-polar because I don't even got to look it up. Whatever the electronegativity is, which I know it's 3.4, but 3.4 minus 3.4 is 0. So it's a non-polar covalent bond. And then passes the test. This is a non-polar molecule. So I just want you to know that I cut this little examples right off of the top page of the UDO. So the top page of the UDO on the other side is done. You need to be able to draw the molecules. Then you need to be able to do the polar covalent bond, which was from video 11. And then now we did symmetry for the entire molecule, put unit or video 11 together and unit 12 together to do this whole piece. And now you can finish the page. Guess what?